Welcome to a hidden world where nature's engineers construct a marvel of cooperation and complexity.
We explore the incredible life of the honeybee colony, a true superorganism.
Each hive functions as a single, unified entity, with thousands of individuals working towards common goals.
Dr. Evelyn Reed, an entomologist, will guide us through this intricate society.
Inside, a highly organized city thrives, far more complex than meets the eye.
Every honeybee has a specific role, contributing to the colony's survival.
The colony's success hinges on incredible teamwork and specialization.
At the heart of the colony is the queen bee, the sole reproductive female. Her primary role is to lay eggs, ensuring the continuation of the colony. She can lay up to 2,000 honeybee eggs a day, a tireless effort.
These tiny honeybee eggs are the future of the colony, each destined for a specific role.
Without a healthy queen bee, the colony cannot survive.
The queen bee's presence orchestrates the entire hive's behavior.
Just 3 days after being laid, the honeybee egg hatches into a voracious honeybee larva. Nurse worker honeybees constantly feed the growing honeybee larvae, fueling their rapid development. A honeybee larva will molt several times, growing significantly in just 5 to 6 days. Once fully grown, the honeybee larva is capped, beginning its transformation into a honeybee pupa. Within the sealed cell, the honeybee pupa undergoes metamorphosis, a remarkable change.
Over about 12 days, the honeybee pupa develops into a fully formed adult honeybee.
Finally, a new worker honeybee emerges, ready to contribute to the superorganism.
You can see on the diagram, the complete metamorphosis involves 4 stages: egg, larva, pupa, and the mature adult honeybee.
Each worker honeybee's life is a progression of specialized tasks, starting young.
The youngest worker honeybees begin their lives as housekeepers, cleaning the hive.
As they age, their glands develop, allowing them to produce royal jelly and care for honeybee larvae.
Later, they become builders, constructing and repairing the intricate wax comb.
Other roles include ventilation, water collection, and processing nectar into honey.
They diligently regulate the hive's temperature, a crucial task for colony health.
Then, the worker honeybee becomes a forager, venturing outside for nectar and pollen.
Foragers share their bounty, ensuring the hive's food supply is constantly replenished. Pollen, a vital protein source, is stored as bee bread for the growing honeybee larvae.
This age-based division of labor ensures maximum efficiency for the entire superorganism.
As worker honeybees near the end of their lives, they often take on guard duty.
They protect the colony from intruders, a selfless act for the greater good.
Among the worker honeybees and queen bee are the drone bees, the male members of the colony.
Their sole purpose is to mate with a new queen bee, usually from another colony. Drone bees do not forage, build, or care for honeybee larvae.
Every member, from queen bee to drone bee, plays a vital part in this living system.
The efficiency of the honeybee colony is truly remarkable.
It's a testament to natural engineering and the power of cooperation.
And this superorganism's intricate dance continues, day in and day out. The industrious worker bee returns, a vital harvest on its tiny legs. Its journey home marks the first step in transforming raw resources into colony sustenance. Once inside, the pollen is carefully deposited into designated cells.
This packed pollen, or bee bread, is a crucial protein source for the entire colony.
Pollen provides essential proteins, vitamins, and minerals, fueling bee development.
Beyond pollen, nectar collection is equally vital, the raw material for honey. Each bee can visit hundreds of flowers, accumulating nectar in its special honey stomach.
With its precious cargo, the nectar-laden bee makes its way back to the hive.
Inside, nectar is passed mouth to mouth, undergoing enzymatic changes with each transfer.
This process reduces water content and introduces enzymes, initiating the honey-making process.
Nectar, primarily sucrose, is converted into fructose and glucose, the sugars of honey.
Observing the hive directly offers insights into this complex food production.
Here we can see the incredible collective effort of the bees.
Notice the fanning bees. They are crucial for dehydrating the nectar.
This rapid fanning evaporates excess water, concentrating the sugars.
Once the honey reaches the perfect moisture content, bees cap the cells with beeswax.
Honey serves as the colony's primary food source, especially vital during winter months.
But how do bees communicate the location of abundant food sources?
The Waggle Dance is an intricate map, sharing precise directions to nectar and pollen.
The angle relative to the sun indicates direction. The duration signifies distance.
At the heart of every thriving colony is the queen honeybee, the sole egg layer. Her devoted attendants feed and groom her, ensuring her well-being and productivity.
She lays thousands of eggs daily, determining the colony's growth and future.
With precision, the queen honeybee lays an egg in each prepared cell. Each egg holds the potential for a new worker, drone, or even a future queen.